Hello students, welcome to this lecture on permutations and combinations. In this lecture, we will cover NCERT miscellaneous examples 20 to 23 and miscellaneous exercise. This is disclaimer. In this lecture, we will first look at NCERT miscellaneous examples 20, 21, 22 and 23. Then we will look at NCERT miscellaneous exercise. Okay, there we will understand how to solve the miscellaneous exercise on this chapter. So let's start today's lecture. In this example asks us how many words with or without meaning, each of three vowels and two consonants, can be formed from the letters of the word involute. Okay, so we have to find number of words with or without meaning. Okay, so here you can see, first identify the vowels. So in this word involute, we have vowels I, O, U, E and consonants N, V, L, T. Okay, and then we have to find how many words can be formed with or without meaning, each of three vowels and two consonants can be formed from the letters of the word involute. Okay, so let's try to solve this example first. Let's start the solution step by step. Given that three vowels and two consonants in the word involute. Okay, so here are three. We have to find the number of words with or without meaning, each of three vowels and two consonants. Okay, so in this word involute, here you can see I, O, U, E. Four vowels are present in this word. Okay, and N, V, L, T, these are consonants. Okay, and we have to choose three vowels and two consonants of the word involute. Let's identify the vowels in involute. We have four vowels I, O, E, U. Next, let's look at the consonants. The word involute contains four consonants N, V, L, and T. Now, let's calculate the number of ways to select three vowels from the four available vowels. Okay, so we use here the combination formula, which is NCR equal to n factorial upon r factorial times n minus r factorial. So the number of ways of selecting three vowels out of four is 4c3 equal to 4 factorial upon 3 factorial times 1 factorial. Now simplifying, we find that 4c3 is 4 factorial upon 3 factorial times 1 factorial. As we know the formula, n factorial is equal to n times n minus 1 factorial. So 4 factorial can be written as 4 times 3 factorial. So after simplifying, we will get 4c3, this is equal to 4 times 3 factorial upon 3 factorial. So here 3 factorial will be cancelled out to each other. Okay, so further simplify it. So further simplified, 4c3 will become 4. Okay, so we have determined that there are 4 ways to choose the vowels. Okay, First, we need to select two consonants from the four available consonants in involute. So we use the combination formula NCR equal to n factorial upon r factorial times n minus r factorial. Okay, so which is denoted as 4c2. So 4c2, this is equal to 4 factorial upon 2 factorial times 2 factorial. Here, factorial rule where n factorial is equal to n times n minus 1 factorial. Okay, in simplifying a factorial expression, the solution requires the student to recognize that 4 factorial can be written as 4 into 3 into 2 factorial and apply this to both numerator and denominator. So 4c2 will become 4 into 3 into 2 factorial upon 2 factorial into 2 factorial. Okay, so here you can observe that in numerator and denominator 2 factorial as a common. So we can now cancel out 2 factorial in numerator and denominator. After simplifying, we find there are 6 ways to choose two consonants from the 4 available. Now, let's think about how we found we found 4c2, okay, and how we find 4c3. Okay, so now we are going to find the number of words with or without meaning. Each of 3 vowels and 2 consonants can be formed from the letters of the word involute. Now, using multiplication principle. Multiplication principle states that if there are m ways to perform one task and n ways to perform another task, then there are m into n ways to perform both tasks together. Okay, so now we are applying this theorem and we will find the answer. Now, we calculate the total number of combinations of 3 vowels and 2 consonants, which is 4 into 6 equal to 24. Okay, so the number of combinations of 3 vowels and 2 consonants is 24. Clear? I think it is clear to all of you now. The number of combinations of 3 vowels and 2 consonants is 24. Okay, so now each of these 24 combinations has 5 letters which can be arranged among themselves in 5 factorial ways. Okay, finally we multiply the number of combinations by the number of arrangements to find the total number of different words that can be formed. Okay, so therefore the required number of different words is 24 into 5 factorial is equal to 2880. Okay, so the answer is 2880. I hope this example is clear to all of you. So now let's move to the next example. In this example, we have a group consists of 4 girls and 7 boys. So in how many ways can a team of 5 members be selected if the team has first no girl? Okay, so find number of ways can a team of 5 members be selected if the team has no girl. So let's try to solve this example. So let's start the solution of the first part. Given that a group consists of 4 girls and 7 boys, in which 5 members to be selected without girls. Since the team will not include any girl, so therefore only we will consider boys for selection. Okay. Now, to find number of ways to select 5 boys from 7, we use combination formula So this is represented as 7C5 ways. Now let's calculate 7C5. So using the combination formula, NCR equal to n factorial upon r factorial times n minus r factorial. Okay, so 7C5, this is equal to 7 factorial upon 5 factorial times 2 factorial. Simplifying further, we calculate 7 into 6 into 5 factorial upon 5 factorial times 2. Since notice that here 5 factorial cancel to each other, and we use here the formula n factorial is equal to n times n minus 1 factorial. After simplifying, we find that the number of ways to select the team is 21. Therefore, the number of ways a team of 5 members without girls is 21. Okay, so there are 21 ways to form a team of 5 members without including any girls. Clear? I think you are getting my point and it's clear to all of you. So now let's move to the second part of this example. So in this part, we have to find here number of ways can a team of 5 members be selected if the team has at least one boy and one girl. Okay, so first of all, try it yourself. Let's solve this example step by step. To start, we know we have a group of 4 girls and 7 boys. Okay, so our task is to form a team of 5 members with at least one boy and one girl. Okay, so the condition of having at least one boy and one girl in the team is crucial. Okay, so at least one boy and one girl are to be there in every team. Let's consider the first possible team composition, that is one boy and 4 girls. Okay, so this is the first possible team composition. Next, we have the second team composition. Okay, that is 2 boys and 3 girls. Okay, so this is another valid combination that meets the requirement of having at least one boy and one girl. Another possibility is to select 3 boys and 2 girls. Finally, we can consider a team with 4 boys and 1 girl. Okay, so this is the last combination that ensures at least one boy and one girl are included. Now we will apply multiplication principle to calculate the total number of ways to form the team. Okay, so remember multiplication principle rule. Okay, so if there are m ways to do one task and n ways to do another task, then there are m into n ways to perform both tasks together. Therefore, let's consider the case where we select one boy and 4 girls. Okay, so we can calculate the number of ways to do this using combinations 7C1 into 4C4. Okay, this means choosing one boy from 7 and all girls from the group. Next, we will take second case, 2 boys and 3 girls. Okay, so 2 boys and 3 girls can be selected in 7C2 into 4C3 ways. Now let's look at selecting 3 boys and 2 girls. Okay, so 3 boys and 2 girls can be selected in 7C3 into 4C2 ways. Now finally consider the case where we select 4 boys and 1 girl. So 4 boys and 1 girl can be selected in 7C4 into 4C1 ways. To find the total number of ways to form the team with at least one boy and one girl, we sum of all the combinations. Okay, so the required number of ways is 7C1 into 4C4 plus 7C2 into 4C3 plus 7C3 into 4C2 plus 7C4 into 4C1. Now let's break down the calculations using the formula for combinations. NCR equal to n factorial upon r factorial times n minus r factorial. Okay, so you will get this expression. Okay, 7 factorial upon 1 factorial times 6 factorial into 4 factorial upon 4 factorial into 0 factorial plus 7 factorial upon 2 factorial times 5 factorial into 4 factorial upon 3 factorial into 1 factorial plus 7 factorial upon 3 factorial into 4 factorial times 4 factorial upon 2 factorial into 2 factorial plus 7 factorial upon 4 factorial into 3 factorial into 4 factorial upon 3 factorial into 1 factorial. So using the property n factorial is equal to n times n minus 1 factorial. So this helps us calculate combinations efficiently. Okay, so we get here 7C1 into 4C4 plus 7C2 into 4C3 plus 7C3 into 4C2 plus 7C4 into 4C1. This is equal to 7 into 6 factorial upon 1 into 6 factorial into 4 factorial upon 4 factorial into 1 plus 7 into 6 into 5 factorial upon 2 into 5 factorial into 4 factorial into 3 factorial upon 3 factorial into 1 plus 7 into 6 into 5 into 4 factorial upon 3 factorial into 4 factorial into 4 into 3 into 2 factorial upon 2 factorial into 2 factorial plus 7 into 6 into 5 into 4 factorial upon 4 factorial into 3 factorial into 4 factorial into 3 factorial upon 3 factorial into 1 factorial. After computing the individual combinations, we sum them up to find the total number of ways to form the team. This is equal to 7 into 1 plus 21 into 4 plus 35 into 6 plus 35 into 4. The final result is 441. So there are 441 ways to form a team of 5 members with at least one boy and one girl. So I hope this is clear to all of you. Therefore, the number of ways a team of 5 members with at least one boy and one girl is 441. So now let's move to the another part. So in this part, we have to find the number of ways can a team of 5 members be selected if the team has at least 3 girls. So let's see the solution. So let's solve the third part of example 21 step by step. To start, we need to understand what has been given to you. Okay, so given that a group of consists of 4 girls and 7 boys, in which 5 members to be selected with at least 3 girls. Now, since the team has to consist of at least 3 girls, the team can consist of 3 girls and 2 boys. This is first scenario. The second scenario is having 4 girls and 1 boy. Okay, and note that the team cannot have 5 girls because the group has only 4 girls. Now let's calculate the number of ways to select 3 girls and 2 boys. So we use here the combination formula. So choosing 3 girls from 4 and 2 boys. 3 girls and 2 boys can be selected in 4C3 into 7C2 ways. For the scenario with 4 girls and 1 boy, so 4 girls and 1 boy can be selected as 4C4 into 7C1 ways. So now the required number of ways is 4C3 into 7C2 plus 4C4 into 7c1. So this is the representation by the expression. Okay. Now, using the combination formula, NCR equal to n factorial upon r factorial times n minus r factorial. Okay. So for the first one, 4c3 can be written as 4 factorial upon 3 factorial into 1 factorial. Okay, and 7c2 can be written as 7 factorial upon 2 factorial times 5 factorial. And 4c4, this is basically 4 factorial upon 4 factorial into 0 factorial. And 7c1 is basically 7 factorial upon 1 factorial times 6 factorial. Okay, so simplify this and add them. So simplify further, we calculate each combination and we use here the formula n factorial is equal to n times n minus 1 factorial to simplify this. Okay, so here you can see this is equal to 4 factorial upon 4 factorial into 1 into 7 into 6 factorial upon 1 into 6 factorial plus 4 into 3 factorial upon 3 factorial into 1 into 7 into 6 into 5 factorial upon 2 into 5 factorial. Okay, now cancel out common terms. So adding these results gives us total number of ways is 1 into 7 plus 4 into 21. And the final calculation yields 7 into 84 equal to 91. Okay, so this is the total number of ways to form a team of 5 members with at least 3 girls. Therefore, there are 91 ways to select a team of 5 members with at least 3 girls. I hope it's clear to all of you. Now, let's look at miscellaneous example 22. Okay, so we have to find the number of words with or without meaning which can be made using all the letters of the word again if these words are written as in a dictionary. So what will be the 50th word? Okay, so first of all, try it yourself. Let's solve this example. Given that the letters of the word again, okay, so notice that it consists of 5 letters. So there are 5 letters in the word again in which A appears 2 times. Now, therefore, by using theorem 4 states that if the number of permutations of n objects where p1 objects are the first kind, p2 are the second kind, and dot 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 pk are the kth kind, and the rest, if any, are of different kinds, is basically n factorial upon p1 factorial times p2 factorial times p3 factorial into dot 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 pk factorial. Now, applying this formula, we calculate the number of permutations as 5 factorial divided by 2 factorial. Here n is 5 and p1 is 2, since a appears twice and other letters are distinct. Okay, now let's calculate. So if we simplify using the formula n factorial is equal to n times n minus 1 factorial, so 5 factorial upon 2 factorial can be written as 5 into 4 into 3 into 2 factorial upon 2 factorial. Then after further simplifying, you will get 5 factorial upon 2 factorial is 5 into 4 into 3, and after multiplying you will get this is equal to 60. Okay, so first we need to determine the number of words that start with the letter A. So if we fix the letter A at the extreme left position, okay, and then we have to find the number of words starting with A. We then rearrange the remaining 4 letters taken all at a time. Okay, so there will be as many arrangements of these 4 letters taken 4 at a time as there are permutations of 4 different things taken 4 at a time. Now, the number of words starting with A is 4p4 equal to 4 factorial is equal to 24, since npn is equal to n factorial. Then, by using theorem 4, the number of permutations of n objects, so where p1 are the first kind, P2 are the second kind, and the dot dot Pk are the kth kind, and the rest, if any, are of different kinds, is n factorial upon P1 factorial into P2 factorial into dot 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 Pk factorial. So starting with G, the number of words as after placing G at the extreme left position is 4 factorial upon 2 factorial. Here n is 4 and P1 is 2. Let's simplify the expression. We calculate 4 factorial as 4 into 3 into 2 factorial, since n factorial is equal to n times n minus 1 factorial. So 4 factorial upon 2 factorial, this is simply equal to 4 into 3 into 2 factorial upon 2 factorial. So here you can see now 2 factorial as common. So the 2 factorial cancel out. So after simplifying, we find that there are 12 possible words starting with G. Now let's focus on the letters we have left after rearranging some of them. So we have 2 A's and 1 I and 1 N. Okay. Similarly, there are 12 words starting with the next letter I. Now let's add up the odds we have counted so far. So we have 24 words starting with A, 12 words with G, and another 12 with I. So totaling 48 words. Okay, so the total number of words so far obtained is 48. Now find 49th word. Okay, so the 49th word is our list is NAAGI. Finally, the 50th word is NAAIG. Okay, and this is our final answer. So I hope it's clear to all of you. So now let's move to the next example. Look at miscellaneous example 23. This example asks to find the number of numbers. Okay, how many numbers greater than 1 0 0 0 0 0. Okay, 1 after 1 there we have 6 zeros. Okay, so can be formed by using the digits 1 2 0 2 4 2 4. Okay, let's solve this example step by step. We are tasked with forming numbers greater than 1 0 0 0 0. Okay, using the digits 1 2 0 2 4 2 and 4. Since 1 0 0 0 0 0 0 is a 7-digit number, so we have exactly 7 digits to work with. So any number we form must also be a 7-digit number. Okay, therefore the numbers to be counted will be 7-digit only. Also the numbers have to be greater than 160. To satisfy the condition of being greater than 1660, our numbers can begin with the digits 1 2 or 4. Okay, these are the only options that will ensure the number is sufficiently large. Therefore, by using theorem 4, which help us calculate permutations of objects with identical items. Okay, that is n factorial upon p1 factorial into p2 factorial into dot dot pk factorial. The number of numbers beginning with 1 is 6 factorial upon 3 factorial into 2 factorial. Here n is 6 and p1 is 2. Now simplifying the expression, we get 6 times 5 times 4 upon 2. This is equals to 60. When 1 is fixed at the extreme left position, the remaining digits to be arranged will be 0, 2, 2, 2, 4, 4, in which there are 3 2s and 2 4s. Now we will apply theorem 4, which helps us calculate permutations when some objects are identical. The formula is n factorial upon p1 factorial into p2 factorial into dot 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 pk factorial. Next, we will calculate the total number of numbers beginning with 2. Okay, total numbers beginning with 2 is 6 factorial upon 2 factorial times 2 factorial. This is equal to 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial into 2 factorial. Okay, so 2 factorial will be cancelled out, and it will become 6 into 5 into 2 into 3. The result is 180. Now, the total numbers beginning with 4 is 6 factorial upon 3 factorial. This is equal to 6 into 5 into 4 into 3 factorial upon 3 factorial. Simplifying the expression, we multiply 6 by 5 and then by 4. Then the final calculation will be 120. Thus, the required numbers is 60 plus 180 plus 120. This is equal to 360. Therefore, the numbers greater than 160 can be formed by using the digits 1, 2, 0, 2, 4, 2, 4 is 360. I hope this example is clear to all of you. So now let's move to the next portion of this lecture. Now we will discuss miscellaneous exercise. Question number 1. Okay, so question number 1 asks us to find number of words with or without meaning. Each of 2 vowels and 3 consonants can be formed from the letters of the word daughter. Okay, so let's find how many words with or without meaning we have with each of 2 vowels and 3 consonants from the word daughter. Let's solve this question step by step. First, let's identify the vowels in daughter. Okay, so there are 3 vowels, namely A, U, E. Now let's look at the consonants. There are 5 consonants: D, G, H, T and R. Now let's calculate number of ways of selecting 2 vowels out of 3 vowels is 3C2, and using here the combination formula NCR equal to N factorial upon R factorial times N minus R factorial. So you will get 3C2 equal to 3 factorial upon 2 factorial times 1 factorial. This is equal to 3 times 2 factorial upon 2 factorial times 1 factorial. After calculation, you will get 3C2 is equal to 3. Okay. First, we need to select 3 consonants from the 5 available in daughter. So we use the combination formula NCR equal to N factorial upon R factorial times and N minus R factorial. Okay, so the number of ways of selecting 3 consonants out of 5 consonants is 5C3. This is equal to 5 factorial upon 3 factorial times 2 factorial. This is equal to 5 into 4 into 3 factorial upon 3 factorial times 2 factorial. After simplifying, we find that there are 10 ways to choose 3 consonants out of 5 consonants. Now, let's apply the multiplication rule. This rule states that if there are m ways to do one task and n ways to do another task, then there are m into n ways to do both tasks. Now, using the multiplication rule, we calculate the number of combinations of 2 vowels and 3 consonants as 3 times 10, which is equals to 30. Okay, so this gives us the total number of ways to select the letters. So each of these 30 combinations of 2 vowels and 3 consonants can be arranged among themselves in 5 factorial ways. Okay, multiplying the number of combinations by the number of arrangements, okay, we find that there are 3600 different words possible. Therefore, the number of words that can be formed from daughter using 2 vowels and 3 consonants is 3600. Okay, I hope it's clear to all of you. So now let's move to the next question. This question asks us how many words with or without meaning can be formed using the letters of the word equation at a time so that the vowels and consonants occur together. So students, first of all, try it yourself. Let's solve this question step by step. First, let's identify the vowels in equation. Okay, so we have 5 vowels in equation odd. So they are namely A, E, I, O, U. Okay, and recognizing these vowels is a crucial because they need to be treated as a single unit in our permutations. And there are 3 consonants, namely Q, T, and N. Since while the vowels and consonants have to occur together, so both A, E, I, O, U and Q, T, N can be assumed as single objects. Okay, then the permutations of these two objects taken all at a time are counted. Okay, so this number would be 2p2. This is equal to factorial, okay, corresponding to each of these permutations. There are 5 factorial permutations of 5 vowels taken all at a time. Also, there are 3 factorial permutations of the 3 consonants taken all at a time. Hence, by multiplication rule, if there are m ways to perform one task and n ways to perform another task, then there are m into n ways to perform both tasks. So, by applying the multiplication rule, we calculate the total number of words as 2 factorial into 5 factorial into 3 factorial. This is equal to 1440. Okay. Therefore, the number of words from word equation with the vowels and consonants occur together is 1440. So I hope it's clear to all of you. So now let's move to the next question. This question have a committee of 7 has to be formed from 9 boys and 4 girls. Okay, so this person asks us to ask us how many ways can this be done when the committee consists of exactly 3 girls, okay, at least 3 girls and at most 3 girls. So in this question we have basically 3 parts. In first part we have exactly 3 girls. For that we have to find number of ways when the committee consists, okay, and consists of exactly 3 girls, and then we have to find how many ways can this be done when the committee consists of at least 3 girls, okay, and then we have to find in how many ways can this be done when the committee consists of at most 3 girls. Clear? So first of all, try it yourself. Let's solve this step by step. Given that a committee of 7 has to be formed from 9 boys and 4 girls. For part 1, we need to exactly 3 girls in the committee. This means the remaining members, 4 in total, must be boys. Now, we will apply multiplication rule. This rule states that if there are m ways to perform one task and n ways to do another task, then there are m into n ways to do both tasks together. Now, applying multiplication rule, Okay, so then the required number of ways is 4c3 into 9c4. This is equal to 4 factorial upon 3 factorial into 1 factorial into 9 factorial upon 4 factorial into 5 factorial. So further we simplify the combination calculations. So notice how we cancel out the factorials. Okay, so here you can see this expression 4 into 3 factorial upon 3 factorial into 1 into 9 into 8, 8 into 7 into 6 into 5 factorial upon 4 into 3 into 2 into 1 into 5 factorial. So further simplify, and we will multiply by 9 by 8 and by 7. Okay, so you will get 9 into 8 into 7. The final result will be 504 ways. Okay, so that required number of ways is 504. Therefore, the committee of 7 has to be formed from the 9 boys and 4 girls. Exactly 3 girls is 504. So I hope it's clear to all of you. Now let's move to the next question. So now look at second part of this question. Since at least 3 girls are to be there in every committee, so the committee can consist of 3 girls and 4 boys or 4 girls and 3 boys. Now using multiplication rule, 3 girls and 4 boys can be selected in 4c3 into 9c4 ways, and 4 girls and 3 boys can be selected in 4c4 into 9c3 ways. Now using addition rule, so addition rule states that if there are 2 jobs which can be performed independently in m and n ways respectively, then either of 2 jobs can be performed in m plus n ways. So the required number of ways is 4c3 into 9c4 plus 4c4 into 9c3. This is equal to 4 factorial upon 3 factorial into 1 factorial multiplied with 9 factorial upon 4 factorial into 5 factorial plus 4 factorial upon 4 factorial into 0 factorial into 9 factorial upon 3 factorial into 6 factorial. So further simplify and you will get this expression, and this is equal to 9 into 8 into 7 plus 3 into 4 into 7. This is equal to 504 plus 84, and the total number of ways is 588. Therefore, the committee of 7 has to be formed from 9 boys and 4 girls with at least 3 girls is 588. Now look at third part of this question. So in third part we have to take at most 3 girls in the committee. So since at most 3 girls are to be there in the every committee, so the committee can consist of 3 girls and 4 boys and 2 girls and 5 boys, or 1 girl and 6 boys and no girl and 7 boys. So using multiplication rule, so multiplication states that if there are m ways to do one task and n ways to do another task, then there are m into n ways to do both tasks. So 3 girls and 4 boys can be selected in 4c3 into 9c4 ways. 2 girls and 5 boys can be selected in 4c2 into 9c5 ways. And 1 girl and 6 boys can be selected in 4c1 into 9c6 ways. No girl and 7 boys can be selected in 4c0 into 9c7 ways. Now using addition rule, it states that if there are 2 jobs which can be performed independently in m and n ways, then either of the 2 jobs can be performed in m plus n ways. Now the required number of ways, 4c3 into 9c4 plus 4c2 into 9c5 plus 4c1 into 9c6 plus 4C0 into 9C7. By using the formula NCR equal to n factorial upon r factorial times n minus r factorial. This is equal to 4 factorial upon 3 factorial into 1 factorial into 9 factorial upon 4 factorial into 5 factorial plus 4 factorial upon 2 factorial into 2 factorial into 9 factorial upon 5 factorial into 4 factorial plus 4 factorial upon 1 factorial into 3 factorial into 9 factorial upon 6 factorial into 3 factorial plus 4 factorial upon 0 factorial into 4 factorial into 9 factorial upon 7 factorial into 2 factorial. This is equal to 4 into 3 factorial upon 3 factorial into 1 factorial multiplied with 9 into 8 into 7 into 6 into 5 factorial upon 4 into 4 factorial into 5 factorial plus 4 into 3 into 2 factorial upon 2 factorial into 2 factorial into 9 into 8 into 7 into 6 into 5 factorial upon 5 factorial into 4 factorial plus 4 into 3 factorial upon 1 factorial into 3 factorial into 9 into 8 into 7 into 6 factorial upon 6 factorial into 3 factorial plus 4 factorial upon 0 factorial into 4 factorial into 9 into 8 into 7 factorial upon 7 factorial into 2 factorial. This is equal to 504 plus 756 plus 336 plus 36 and total is 1632. So there are 1632 ways to form the committee with at least 3 girls. So therefore there are 1632 different ways to be formed from 9 boys and 4 girls with at most 3 girls. Okay. Now look at question number 4. So this question asks us if the different permutations of all the letters of the word examination are listed as in a dictionary. So how many words are there in this list before the first word starting with E? First of all, try it yourself. Let's solve this question step by step. So in the given word examination, there are 11 letters out of which AIN appear two times and all the other letters appear only once. So the words that will be listed before the words starting with E in a dictionary will be the words that start with A only. So therefore, to get the number of words starting with A, the letter A is fixed at the extreme left position. Then the remaining 10 letters taken all at a time are rearranged. So since there are 2I and 2N in the remaining 10 letters, so then by theorem 4, the permutation is n factorial upon p1 factorial into p2 factorial into dot dot pk factorial, where p1 are the first kind identical objects, p2 are the second kind identical objects, and dot dot pk is the kth kind identical objects, and rest if any other different kinds. So number of words starting with is 10 factorial upon 2 factorial into 2 factorial. This is equal to 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial into 2 factorial. After simplifying, you will get this is equal to 907200. Thus, the permutations of all the letters of the word examination with first word starting with E is 907200. So I hope this question is clear to all of you.